More weather. Weather watching on other planets. This is found on page 14 of your TCI book. Savvy travelers know how to check the weather of their destination before packing for a trip. No one would want to be caught in only a t-shirt in freezing weather. If you were an astronaut traveling to another planet, what kind of weather would you prepare for? Very hot Venus. To have weather, a planet must have an atmosphere. Mercury doesn't have an atmosphere and consequently doesn't have any weather. Venus, however, does have an atmosphere that is thick and dense with clouds of sulfuric acid, and so it experiences very extreme weather. The caption underneath this picture, Venus's atmosphere traps energy and creates fiery temperatures. An artist drew what the weather might look like on this hot planet. In this drawing, lightning flashes out from thick yellow sulfuric acid clouds. Mars has dust storms that can cover areas as large as a continent. The hazy areas of this photo are parts of a large dust storm as viewed by a spacecraft orbiting the planet. The clouds on Venus act like a blanket, trapping energy and causing temperatures to reach as high as 471 degrees Celsius. If you could venture to Venus, and if you weren't crushed first by the weight of its atmosphere, you would need a very insulated spacesuit to protect you from the heat. Mars has dust storms that can cover areas as large as a continent. The hazy areas of this photo are parts of a large dust storm as viewed by spacecraft orbiting the planet. Massive Martian storms. You would not have to worry about a crushing atmosphere if you traveled to Mars because Mars has a very thin atmosphere. The atmosphere is so thin that its weight on Mars is less than 1% of the weight of Earth's atmosphere at sea level. However, because Mars' atmosphere is so thin, it cannot hold energy as well as Earth's atmosphere. So, Mars' average temperature, minus 63 degrees Celsius, is much lower than Earth's average temperature of 14 degrees Celsius. So if you do a little math there, there's a 77 degree difference between the cold temperature, average temperature on Mars, and the slightly more temperate temperature here on Earth. But like the Earth, Mars has seasons and temperature variations. Mars' poles can be as cold as minus 125 degrees Celsius in the winter, and its equator can be as hot as 20 degrees Celsius in the summer. A dust devil is a swirling column of air that kicks dust high in the air. This dust devil on Mars is about 800 meters tall and 30 meters wide. Wow. The temperature differences on Mars cause wind, which can reach speeds of around 96 to 100 kilometers per hour, or about the speed of cars on a highway. The Martian winds regularly whip up dust from the planet's dry surface that forms dust devils reaching almost 800 meters into the air. Also, several times a year, dust storms lasting for weeks cover areas as big as some continents. On rare occasions, Mars has massive dust storms that circle the entire planet. These storms cause problems for rovers, which are remotely controlled solar-powered research vehicles sent from Earth to explore Mars. The storms block sunlight from reaching the rover's solar panels. The rovers depend on solar energy to run. If astronauts did go to Mars, they too would rely on solar energy. And if a dust storm hit while they were on the planet, they would need to have another source of energy. Jupiter's gigantic weather. I'm going to read the caption underneath the picture first. Jupiter's atmosphere is colorful thanks to clouds, storms, and auroras. In this photo, the great red spot, which is twice as white as Earth, is in the lower right. The bright blue streaks around the planet's north poles are auroras. Now I'm going back up to the top now, Jupiter's gigantic weather. The four planets farthest from the Sun, Jupiter, Saturn, Uranus, and Neptune, all have weather because they all have atmospheres. In fact, these planets are called gas giants, which means that they are mostly made of gases and do not have a solid surface like Earth or Mars. We've already read the caption, skipping down the next paragraph. Jupiter is the largest gas giant and the largest planet in the solar system. It is so large that all the other planets in the solar system could fit inside of it. Jupiter's giant size comes with a giant-sized weather. Large storms swirl and can be seen moving across its colorful, cloud-covered atmosphere. Jupiter's largest and most famous storm even has a name, the Great Red Spot. Now that's a storm. The Great Red Spot has been storming for more than 100 years and possibly for more than 300 years. It's so large that it is twice as wide as our entire planet. Winds inside the spot can reach speeds of a little over 640 kilometers per hour, which is twice the wind speed of the most powerful hurricanes on Earth. Up above, we talked about those auroras that were found at the northern part of Jupiter. Well, here's a picture of auroras here on Earth. I can tell it's on Earth because, well, those are trees. And here's a description. Auroras are light shows produced when charged particles strike gases in our planet's atmosphere. On Earth, auroras are usually seen near the poles and can be green, purple, red, blue, or a mixture of these colors. Jupiter also has huge, never-ending auroras that appear near its poles and are much more energetic than the ones found on Earth. Auroras are light shows produced when high-energy particles collide with gas particles in a planet's atmosphere. The charged particles strike the gas particles, causing them to give off light. Jupiter is not the only planet that has auroras. Earth and other planets have them too. Solar storm effects on planets. Auroras are the result of a different kind of weather, solar storms. Solar storms originate from the sun, but they are not like storms on Earth or any other planet. Storms on planets result from moving air masses in the atmosphere and stay in a planet's atmosphere. Solar storms, on the other hand, are a result of magnetic field activity within the sun's atmosphere, and some solar storms even leave the sun's atmosphere. The two main types of solar storms are solar flares and coronal mass ejections, CMEs. Solar flares are bright flashes of electromagnetic radiation that reach the topmost layer of the sun's atmosphere. CMEs are bubbles of hot, charged particles that break off from the sun's atmosphere and travel at high speeds away from it. CMEs can reach Earth in about 3 to 4 days. Powerful CMEs can damage electrical power grids and disrupt the electrical systems of satellites, including those used for GPS and television. CMEs are one source of charged particles that cause auroras on Earth, Jupiter, and other planets. On Earth, auroras are usually seen close to the poles, so you don't have to be an astronaut to leave the planet to experience the effects of solar weather. But you might have to travel to places near Earth's poles, in which cases you better pack a lot of warm clothing. Here's the caption underneath this picture. It's a cool picture. Solar storms are a kind of space weather that originates from the sun. A coronal mass ejection, a CME, is a solar storm that breaks off from the sun's atmosphere and carries a bubble of charged particles off into space. In this photo, the loop coming off the sun is the start of a CME.